Hello, my name is Steve Bowler, and welcome to Juniper Border Gateway Protocol BGP Lab number 3. In this lab, we're going to take a closer look at the Next Hop attribute. So the first thing I want to do in this lab is explain our network diagram. We have 3 routers in this lab. We have router 1, router 2, and router 3. Router 1 and router 2 are connected via the 12 network, and router 1 is connected to router 3 via the 13 network. All these routers are created within one single Juniper router in what is known as logical systems. If you're not familiar with logical systems, you might want to go ahead and watch those videos to familiarize yourself with the concept of logical systems. Just a high-level overview of logical systems. They allow you to create within one single physical Juniper router. I can break it up into many different routing processes, or what we can have is virtual routers inside of one physical router, and then we can connect these virtual routers together, our logical systems together, with what's known as logical tunnels. So in this video, all logical tunnels are going to be represented as LT-120.XX. For instance, R1 to R3, that interface is going to be LT-120.13, so LT.13. And then the connection on R3 is going to be LT-120.31. So also we have router 2 has loopback 0.2 with the IP addresses of 2.2.2.0/24 and also the 22 network with /24 as well. Router 3 has the loopback of 0.3 with the 3 network and the 33 network, both /24s. Router 3 is in Autonomous System 200. Router 1 and Router 2 are in Autonomous System 100. So the connection between R1 and R2 is going to be IBGP, or internal BGP, and the connection between R1 and R3 is going to be external BGP, because we have, with external BGP, we have a peering in different autonomous systems. Obviously, Autonomous System 100 to Autonomous System 200. So in this lab, we're going to take a look at the default behavior of the Next Hop attribute and the default behavior of when we advertise these networks on R3 into BGP in Autonomous System 200. We're going to look at how they are passed on to Router 1 in Autonomous System 100, and then how Router 1 is going to pass reachability to these networks to its IBGP peer, which is going to be Router 2. We're going to look at trace options, how to set that up. We're also going to look at some show commands and some we're going to look at some show commands so that we can verify reachability and some of the important aspects of the Next Hop attribute. So let's go ahead and get started. We're going to start by configuring, I should say we have already all the interfaces configured and all the IP addressing. So we can jump straight to BGP. This is a pretty simple network layout. We just have 3 routers. We're going to start on R1. And under R1, we'll go under Edit, Protocols, BGP. And what we're going to do is we're going to create our IBGP group first. We'll do set group IBGP. We're going to create this as the type internal. Then we're going to do set group IBGP. The peer AS is also going to be 100. This is going to be the connection between R1 and R2, because this is a IBGP connection residing in Autonomous System 100. And the last thing we're going to do is the set group IBGP neighbor, and then our peer IP address, which is going to be 12.12.12.2. That's R2's IP. Now we're going to create our connection to router 3. This is going to be, the group type is going to be eBGP. This can be anything. This is just going to be the group name. Obviously we create this so we know exactly what this group is for. This is our external BGP connection to router 3. So we'll do set group eBGP type external. That's indicating an external BGP connection. We're going to do set group eBGP peer AS 200. Obviously router 3 is in autonomous system 200. And then our last command is going to be set group eBGP neighbor, and this is going to be pointing towards router 3's IP address, which is 13.13.13.3. And that should be it for router 1. We'll go ahead and commit those. One second. What this error is telling us is that we must define our local autonomous system when enabling BGP. So I forgot to do this. If we go to the top of the configuration, we do the command set routing options, autonomous system, and we are in autonomous system 100. So R1 is part of autonomous system 100. If you're not familiar with how to set up internal or external BGP, you might want to look at some of my earlier on labs, Juniper BGP Lab 1 and then Juniper BGP Lab 2. So I go over both internal and external BGP in those labs. Now when I go ahead and commit this on R1, I shouldn't see any errors, and we can see the commit has been complete. The next thing we're going to do is we're going to move to router 2. And if we look at our network diagram, router 2 is in autonomous system 100 with R1. On router 2, we're going to set up BGP trace options. And if you're not familiar with BGP trace options, they allow you to track BGP events and log them to a file that we are going to create. And then we're going to go back and we're going to do a show log on that file to see some important events that are happening with BGP. So trace options are kind of like Cisco debugs. If you're familiar with the Cisco iOS, when you do a debug IPBGP, we all know that a debug IPBGP within the Cisco iOS is going to return us BGP events or BGP related information. So trace options are going to allow us to do that within the Juniper Junos. I'm going to show you how to set this up. If you're not familiar with trace options, you can get a very detailed look at trace options in my trace options lab. But for the sake of this video, I'm just going to go under Edit Protocols BGP, and on router 2 we're going to set trace options file. We're going to name our file. We'll just call it BGP Lab 3R2. And then if we do set trace options flag and space question mark, you can see all of these are options that we can set the flag on. So these events will be trapped and logged to our file, which is called BGP Lab 3R2. We're just going to do all events, and then we're going to go ahead and do a show log and match on more specific events within that log. So as you might be thinking, if we do flag all in BGP, we're going to get a lot of information, but we will very quickly siphon through all that information by doing the show log pipe match. So we'll do set trace options flag all. And then the next command we're going to do, and maybe we should do this first, is on the top of the configuration on R2, we'll do set routing options autonomous system 100. Then we're going to do, if we go, let's go under Edit Protocols BGP. We'll do set group IBGP type internal. We're going to do set group IBGP peer AS 100. This is going to be our connection to router 1, which is also in Autonomous System 100. Then we're going to do set group IBGP neighbor 12.12.12.1. That's our connection to R1. So now that we have our BGP configuration done for now, on router 2 what we are going to do is we are going to advertise the loopback 0.2 networks into BGP. We're also going to do that on router 3, but the first thing we're going to do on router 2 is we're going to set up a basic routing policy. If you're not familiar with routing policy, I have a video on how that explains how to create routing policies. So we'll do the command set policy options, policy statement. We'll just call it loop. We'll do term 1, and then we'll do from interface LO 0.2. And then we're going to finish this off. Now that we have a match, we're going to do an action. In this case, we're just going to accept. So what we are saying in this simple policy, routing policy, is that we're just going to match the interface loopback 0.2. And you're probably wondering, well, what are you doing that for? We're going to now go under Edit Protocols BGP. Then we're going to do set group IBGP export loop. So what we're doing is we're exporting this policy that we just created into our internal BGP group. So we'll go ahead and commit that on router 2. And what we should see on router 1, if I do a show BGP summary, we see that we have a connection now with router 2. See that we have 2 active routes. We are receiving 2 routes and accepted 2 routes. If we do a show route on on R1, we can see the 2 and the 22 network now being sent from router 2 to router 1. So our export policy is good on R2. The next thing we want to do is move to router 3 and configure external BGP with R1 and advertise the loopback on R3 into BGP. First thing we'll do from configuration mode, we'll do set routing options, Autonomous System 200. Then we will move to Edit Protocols BGP. Then we're going to do the command set group eBGP, and we'll set that type to external. We'll do set group eBGP peer AS is going to be 100. We'll do the command set group eBGP neighbor 13.13.13.1. That's the connection to router 1. And then now what we want to do is create our simple routing policy. We'll do set policy options, policy statement, loop is going to be the name of our statement. Is our routing policy is going to be loop, and then we'll do from interface loopback 0.3. And now that we have our match, we'll do our action, which is going to be accept. Once that is configured, we'll go back under Edit Protocols BGP. Then we're going to do the command set group eBGP export, and then loop. Set group external BGP, our eBGP export loop. We'll go ahead and commit that on R3. And what we should see is if we go to router 1 and if we do a show BGP summary, we can see the neighbor relationship has just come up between R1 and R3. And we see that the neighbor relationship is in Autonomous System 200. That's where router 3 is. Router 1 is in Autonomous System 100. On R1, if I do a show route, we can see both the 2 network, the 22 network, and also we see the 3 network and the 33 network is reachable from router 1. And we can test this if we just do a simple ping from R1. We'll do ping 2.2.2.2. We have reachability. We'll do a rapid count of 100. You see that we have reachability from router 1 to router 2's loopback. And if we do a ping 3.3.3.3, rapid count of 100, you see that we have reachability as well to the 3 network. If we go to our network diagram, what we just did was we were on router 1 and we did a simple ping to the loopbacks, or the loopback off of router 2 that was successful, and then we also did a ping from router 1 to the loopback on router 3 that was successful. So we have reachability, full reachability from router 1's perspective. Let's look at the trace option file on R2 to see. Actually, before we look at the trace option on R2, let's go to router 2. And we'll do a show route on R2 and see if we can see the 3 network. And right now it looks like router 2 is not receiving the 3 or the 33 network in its routing table. So maybe if we look at the trace option that we created on R2, maybe we'll be able to get some more information. If we do a show log BGP lab 3 R2, and then let's go ahead and try to match on one of the 3 networks. We'll do 3.3.3.0. And with this simple output from our trace option log, we can see that it appears as though we're adding the 3 network into BGP, but it appears as though it is coming up as being hidden from the routing table. Let's go ahead and look at the 33 network as well. We have the same thing coming up with the 33 network. It looks like it's being hidden. So another good command we can do on R2 is the command show route hidden. And we see both the 3 network and the 33 network being learned via BGP, and it appears as though we are also getting some information that it is unusable. Let's go ahead and do show route hidden extensive, see if we can get some more information on what's going on. And with the show route hidden extensive, excuse me, we can see that the protocol next hop is 13.13.13.3. And if we look at our routing table again, if we do a show route, we can easily see that from router 2's perspective, it doesn't have reachability to the 13 network. So obviously these routes are not going to be reachable because we don't have reachability to the next hop in this scenario. We have no way to get to router 3 because it's not in our routing table. There's another good command we can do from router 2. The command is show route receive protocol BGP, and then follow it up with 12.12.12.1. That's our BGP peer. I'm sorry. If we do show route receive protocol BGP, we can see that we have 2 hidden routes. If we do hidden, now we can see the 3 network and the 33 network. We see the next hop as 13.13.13.3, which we saw with the show route hidden extensive, and that showed us that the protocol next hop was router 3 as well, and router 2 does not have reachability to the 13 network. And so this brings us to explaining that iBGP does not change the next hop attribute to itself when it learns routes from eBGP peers and sends them to its iBGP peers. By default, the next hop is the router it learned this information from. So in this case, that's why we see 13.13.13.3 being set as the next hop, because this is router 3. If we look at our network diagram, 13.13.13.3 is the interface between R3 and R1. So these routes are coming in from router 3, being advertised to router 1, and then router 1 is advertising the 3 networks to router 2, but the next hop is not being set to itself. The next hop is actually being installed as 13.13.13.3, which is router 3. So let's go to router 3 and take a look on R3 and see what's going on. If we go to router 3 and do a show route, what we can see is that router 3 is seeing the 2 network and the 22 network. So the show route on router 3 shows these networks in its routing table, so iBGP learned routes are being advertised to Autonomous System 200, and the next hop is valid. We see for the 2 network and the 22 network, we see the next hop is 13.13.13.1, which is R1, and if we do we don't even need to do that. We see the 13 network is directly connected. So let's go ahead and see what happens if we try to ping. We'll do a ping 2.2.2.2, and we'll source this from our 3 network, 3.3.3.3. We'll do a rapid count of 5, and we can see that these pings are unsuccessful. So the routes are in the routing table from router 3's perspective, but we don't have reachability. And that is because if we look at the packet flow in this network diagram, we just did a ping from router 3, we sourced it from our 3 network. So we did a ping to the 2 network, we sourced it from our 3 network. So this ping gets to router 1. If we look on router 1's routing table, we do a show route, router 1 has reachability to both the 3 network and the 2 network. So router 1 takes this packet, sends it, it says, hey, yeah, I have access to the 2 network. I'm learning it via BGP, and I'm going to go ahead and send it to router 2. So router 2 gets this traffic. We do a show route. So router 2 obviously has the 2 network directly attached, so it sees this ping come in, However, when it tries to reply to this ping, in its routing table, it does not have access, or we do not have reachability to the 3 network. We see that it's being hidden, and because the next hop in router 2's routing table is not accessible. So there's a very simple way that we can fix this issue, and that's just to go to router 1 and create a simple routing policy which will configure the next hop self for internal BGP peers. And so what this is going to do is, instead of the next hop being the connection between the eBGP neighbor, the 13.13.13.3 IP, the next hop self will tell router 2 to reach the 3 network. We're going to send it to R1. So the next hop we should see as router 1. This is one of the most common ways to fix this reachability issue. There are other ways you can do this. One of the more common ways to do this as well is to set up a routing policy. We could create a routing policy to export this directly connected interface into our interior gateway protocol, or IGP. That's another more commonly known way to fix this issue. But for the purpose of this lab, we're just going to do next hop self on R1. So let's go to router 1 and get this set up. So we're going to create another simple routing policy. We're going to do the command set policy options, policy statement. We'll just call it NHS for next hop self. We're going to do term 1. And then we're just going to do our action, which is going to be then. We'll do next hop space question mark, and you can see that we have the option for self. So there's a lot more options, but in this lab we're just going to show you how to use self. So we'll do then next hop self and hit enter. Then we're going to go under edit protocols BGP. Then we're going to do the command set group iBGP. Then we're going to export this routing policy that we just created into iBGP. We're going to do set group iBGP export NHS. And that should be it. So if we go to router 2 and do a show route, now it appears as though we have the 3 network and the 33 network in the routing table for router 2. Let's go ahead and take a look at our trace option file on R2 as well. If we do the command show log BGP lab 3 R2, and we'll go ahead and do a match on 3.3.3.0, we can see before we had those routes coming in as hidden, but now we see the 3 network, instead of hidden, it's showing up as active. Let's look at the 33 network as well. We'll match on 33.33.33.0. Let's look at our pass log. We'll go just do a .0.gz. Before we saw that route coming in, the 33 network, as hidden. And now we see it coming in and being actively installed into our routing table. And it is usable. If we do a show route received protocol BGP on the 12.12.12.1, this is the connection to R1, our IBGP neighbor, we also see those two prefixes being learned with the next hop of 12.12.12.1. Before, when we did the show route receive protocol BGP, we saw that they were hidden, so we had to do the hidden option, and we saw the next hop was resolving to 13.13.13.3, which was not in our local routing table. Once we set the next hop self export policy on R1 and sent that information to router 2, we saw that the next hop is now showing up as router 1, which is 12.12.12.1. If we do a show route 3.3.3.0 extensive, this is just another way for us to see the protocol next hop. Before, when we did the extensive, on the hidden routes, show route hidden extensive, we saw the protocol next hop was 13.13.13.3. Now when we do a show route on the 3 network extensive, we see the next hop being set correctly to router 1. And the state as active. Before, if we looked, we saw the state as hidden. So I just wanted to point that out. On R2, if I do a ping 3.3.3.3, source this from 2.2.2.2, do a rapid count of 200, we can see that we are successful and that we have reachability. Let's go ahead and go to router 3 and see if those pings will come back and be successful. Before, we did a ping to the 2 network, sourced it from the 3 network, and they had problems getting there, and we explained that issue. And if I do a ping after I set the next hop self on R1, you see that we have reachability. Let's go ahead and do a ping to the 22 network as well. And as you can see, we are successful there as well. So to wrap things up, this was Juniper Border Gateway Protocol BGP Lab 3. In this lab, we looked at the next hop attribute. We saw you the default behavior when you advertise in one autonomous system, in this case autonomous system 200. We advertised the 3 network to autonomous system 100, which was R1 and R2. We saw that R1 had reachability to both the 2 networks and the 3 networks. However, when R1 passed the 3 networks along to router 2, we saw that the next hop was being set for the 13 network, our router 3. Obviously, router 2 did not have reachability to the 13.13.13.3 IP address. We showed you with trace options what was going on, why those routes were being hidden from the routing table in BGP. And then we showed you on R1 how to configure a simple routing policy that set the next hop to itself instead of router 3. Then we exported this routing policy into the group IBGP, which was our connection to router 2. And then we saw that router 2 had reachability, and those routes were no longer hidden on R2. And then to finish things up, we went to router 2 and did a ping to the networks on R3, and then we went to router 3 and pinged to the networks off of router 2. So this might seem to be a very simple topic, but it can trick a lot of people up when they're trying to understand. If you don't know the default behavior of BGP, both internal and external, then this might trick you up on a lab scenario or a real life scenario when you're trying to troubleshoot BGP. So you always need to familiarize yourself with the BGP Next Hop, its default behaviors, and how to change these behaviors. So thanks for watching, and I hope to see you in the next video.